So today we are going to look at ways of migrating your SQL Server database to AWS using DMS. What I'm also going to talk about is I'm going to quickly talk about different ways of doing that before we jump in to the database migration service part. Just to give you a quick background about myself, my name is Arun, and I currently work as a database engineer with the DMS SET team at AWS. So the agenda for today would be one, to know about different ways to migrate a SQL Server database to AWS. Then we move on to know about how to use the database migration service as such to migrate a SQL Server database to AWS. And then we talk a little bit about the internals of how the database migration service migrates a SQL Server database. I will get into more details about the different phases in the migration, what the database migration service requires you to do from a prerequisite perspective, and what the database migration service actually does in order to be able to migrate the database in the bulk load phase and the ongoing replication phase, and go on to keep one of our supported target databases in complete sync with the source SQL Server database. And then we quickly talk about the advantages of using DMS in database migrations. To conclude the presentation, we will have a short demo where I have the artifacts required to be used by the database migration service in order to migrate your SQL Server databases. I will go on and show you how to do a small migration and what power and advantages the DMS service as such offers customers for migrations. Moving on, so let's quickly talk about different ways to migrate your SQL Server database at the moment. So just to give you a quick background, whenever I state the acronym DMS, I am talking about the Database Migration Service. And whenever I state the acronym SCT, I am talking about the schema conversion tool, which helps you convert your secondary database objects from a source to target. We will dive deep into both of these tools or services in a bit, but I just wanted to make sure I provide you with a background initially so that we're all on the same page. So some of the ways in which you can currently migrate your SQL Server database is just to give you some more background about the ways here. One of the best ways to do a homogeneous migration, by homogeneous migration, I mean migrating a database, a like-to-like database, and doing a lift and shift. For example, going from SQL Server to SQL Server, or Oracle to Oracle, or MySQL to MySQL, and so on and so forth. One of the best ways to do such migrations is to use some of the native migration tools that those database engines already offer in the market. For example, SQL Server offers a way to backup and restore your databases. All you would need to do is take a complete full backup into a .back file, store it in a file system, and then move it into the AWS cloud through whatever way you need to move it using, and then go about restoring that particular database on the AWS cloud. You could either choose to restore it in an EC2 instance where you assume the responsibility of managing and administering the database, or you could put that backup file actually in an S3 bucket in your own AWS account, and then restore it into an RDS instance, which is a managed SQL Server solution that AWS offers. By RDS, I mean the relational database service, which kind of helps customers, just take care of their data from a database perspective, but it takes out some of the administrative actions that a customers need to take, like backups or patches, and everything are managed by AWS itself. So in case you can take some sort of a downtime during your migration, and you are doing a like-to-like lift and shift migration like how we just talked about, backup and restore could be one of the most important options that you could look at, because one, it is really easy to use. Two, because it's a lift and shift, it's going to help you take anything and everything from a database, from data to all your secondary objects like foreign keys, constraints, indexes, and everything else, and then go about getting you an active database instance, which is a copy of the database instance from where you're trying to move that particular SQL Server database from. The second option is for users who cannot take a prolonged downtime. One of the cons of using the backup and restore option is you will not be able to migrate ongoing changes in a particular source database. And that's the reason some of the users who own applications or who engineer applications which cannot take a prolonged downtime decide to go with a migration solution which not only helps them take that bulk copy of the database and create a copy of that particular database in the target instance as such, but they would also want the target instance to remain in complete sync with the source at a given point in time. And some of the native solutions that SQL Server offers, which is not limited to the second point I show here, are replication, SQL Server basic replication. It comes in 3 different flavors, and transaction replication is probably one of the replication features that you can look at to achieve a migration that is something like this. You could use always-on availability groups from SQL Server 2012, and if you have something before that, you could also even look at using mirroring or log shipping and other solutions that come along with SQL Server. And the third option is to use AWS's own service called the Database Migration Service, which not only helps you bulk load data, which is called the full load phase, where it's going to create a copy of your source database system in a preferred target, but it is also going to read through those changes from the transaction log in SQL Server, and it's going to apply them on the target, thus keeping the target in complete sync with the source. So the biggest advantage that DMS offers is it takes care of any of the disadvantages that one or two come with. For example, the biggest disadvantage with number 1 option here is you will not be able to keep your target in complete sync with the source. But some of the disadvantages of the options that come with number 2 are, for example, let's say you're trying to move from an unencrypted instance to an encrypted instance. Some of those native solutions might not work, may or may not work, depending on your use case. So that's where DMS is going to help you migrate that particular database, because what DMS does is logical replication, which I will get more into in a short span of time. But there are ways in which, because DMS reads data like any other application reads data from a database, it's able to read the required data appropriately, and it's able to securely migrate that data using all of the awesome security features that AWS exposes, along with some of those SSL protocols that SQL Server supports, and move them securely and fastly into AWS. Moving on, let's quickly talk a bit more about the database migration service. Firstly, let me touch upon a bit about the process as such. One of the ways in which you do a lift and shift migration or a homogeneous migration is being able to just do a bulk load and then go about applying all the secondary objects and then go about keeping your target in complete sync with the source. So in order to do that, especially in a homogeneous migration scenario, I kind of want to give you a point on what the DMS service as such does. So the DMS service takes care of your data migration, it takes care of your table structure, and it also takes care of your primary key or the unique indexes that in a table that you're trying to migrate. All other secondary objects like foreign keys, constraints, and indexes and stored procedures or functions need to be handled outside DMS. And one of the ways in which you can do that for a homogeneous migration is to just script out those secondary objects yourself and apply them on the target instance, which is depicted by that native tool in that diagram, in the first part of the diagram there, where we convert and copy your schema. And or you could also choose to use our other tool called the AWS schema conversion tool, which has it's a Java-based application which has abilities to connect to your source, connect to your target, and move all the secondary objects that DMS does not move during the actual data migration as such. And once the copy of your schema is available on the target there, whichever option you choose to use, be it the schema conversion tool or be it the native replication tool, you could go ahead and use the database migration service, set it up with respect to its required artifacts, and go about moving your data from the required source to the required target. So how does DMS actually work? So let's look at the process step by step here. And let's assume that you have a group of application users who are using an application and it's connecting to a database in your on-premises environment, like how it is depicted in the diagram here. We are able, and from the on-premises environment as such, we are connecting to your own virtual private cloud in the AWS cloud. And we are going to see how DMS migrates the database that is present in the on-premises environment to a database present in AWS, be it on EC2 or RDS, anything of your choice. So the first thing that we need to do is to start something called a replication instance. This replication instance is going to connect to your source, pull data from the source. It's going to connect to the target and push data to the target so that it can start the migration and complete it. So one of the first things you need to do is to be able to do that. And the second one is you create a couple of artifacts called endpoints. One of them is called the source endpoint, and the other one is called the target endpoints. And you have abilities to create an endpoint connection test from the replication instance that you created in step one, and make sure that your replication instance is able to connect to the source and able to connect to the target at a given point in time. Once that is set up, you create another artifact called migration tasks. So migration tasks, there are different kinds of migration tasks that you can look at, which I'll show you during my demo, but you have different ways of controlling these tasks in a way where you can do a full load only task, which is just going to take a point-in-time copy of your source database and apply that on the target instance. Or you could do something called full load and apply ongoing replication changes. What that will do is it is going to take a bulk load copy of your data from the source, and it's going to keep applying ongoing changes that are going on to the source on the target and keep it in complete sync with the source. And the third option is to just do a replicating ongoing changes only task, where the work of making the bulk load data available falls back on you, where you could just try to take a backup and restore the backup yourself and use replicating ongoing changes only task and keep the target in sync with the source. So once the target is synced, you have, once you are trying to create the task, you have abilities to, select whatever tables you need to select and go about keeping the target in complete sync with the source. And once you see that the target is in complete sync with the source, you can do this with the help from CloudWatch metrics, from the task logs that we expose to our customers, and know that the target is in complete sync with the source. And of course, you can also use that migration validation feature that DMS offers, along with some smoke tests that you can run from the application. And once the target is in sync with the source, you could switch your application users and the application to use a new database in AWS. So that's the entire process that is the best practice to use the service and transfer your source database to a database on AWS. Moving on, we also support multi-AZ instances, just like how the relational database service provides for high availability. And in case something happens or the replication instance goes down because of an infrastructure issue or anything else, and it's not available for a given point in time, or the availability zone goes down, we have abilities to switch you over automatically to another availability zone in which DMS will come up, and it will make sure your tasks are not interrupted at all. So the other, moving on, the other idea about DMS is I kind of quickly wanted to talk about how DMS uses SQL Server as a source as its endpoint. And one of the first things that DMS does is it does a select star on the table during the bulk load phase, and it's going to move your data through the bulk copy utility onto the target instance when going from a SQL Server to another SQL Server migration task. But during the ongoing replication phase, what it does is it's going to use the stored procedure that you have on the screen here, and it's going to enable that particular database you are trying to read those ongoing changes from for replication. And because one of the requirements to use this stored procedure is to have system administrator privileges, when you are trying to use a SQL Server source endpoint with ongoing replication changes, you would need to assign sysadmin privileges to the endpoint user. The second step that we take care of after this is we create a publication artifact with a 1 is equal to 0 filter, which is never true. And one of the reasons we do that is to make sure we have enough logging in the transaction log. For example, once we do this, any update statement or transaction running on the source is going to be logged into the transaction log. And once all the required statements that we need to read to replicate ongoing changes are available in the transaction log, we use the undocumented functions fndblog and fndump dblog to read those changes from the transaction log according to the log sequence number. So that's how we source those changes, put it through another component within the DMS instance called the sorter component, which helps you order those transactions according to commit order on the source, and then push them onto the target like any other application, so that we could keep the target in complete sync with the source. Just another diagram here where I quickly wanted to talk about another process in the background also. So one of the questions that you might have now is, what if we are reading changes, the DMS service is reading changes from the transaction log itself, correct? So what if a portion of the active transaction log is backed up by backed up by the SQL Server instance and goes into another file system where it is residing as a .prn file. So one of the things is, because we track the LSNs ourselves, and because we have the system administrator privileges on the source, we have abilities to look through transaction and transaction log backups as well. It's just that the performance is going to be, the performance of reading from the active transaction log is obviously faster because it's the active transaction log we are reading from using the fndblog function. But we have another way of preventing a transaction log backup from being taken, even for databases where the activity is not that much. We use something called the truncation safeguard table, which you can completely ignore and not use this feature at all. What this table kind of does is it maintains a dummy active transaction on the source database, making sure that DMS reads from the active transaction log for an extended period of time, and at the same time it gives you enhanced performance during the ongoing replication phase. Moving on, what are the advantages of using the database migration service? So one of the things I quite did not touch upon, because I was concentrating on talking about moving a SQL Server database to AWS, is DMS also supports heterogeneous migrations. So what we also do is we have abilities to help you replicate and bulk load data from any of our supported sources like SQL Server, Oracle, MySQL, Postgres, to name a few, to any other database engine that is supported by DMS, which falls under the same set of database engines I talked about. We also support other sources and targets like S3, Redshift as a target, and things like that. So you could mix and match, and you could go back to the drawing board and think about whether you want your entire monolithic SQL Server database to reside in SQL Server itself on AWS, or use some of our other awesome services. For example, one of the better things that our customers do is shift their reporting workloads to Redshift using the DMS service and things like that. So it removes barrier to entry. And because we support ongoing replications and keep the target in complete sync with the source, we do near zero downtime migration, and the only downtime that you're going to face is when you actually switch your application from talking to the source database and then talking to the target database. It is absolutely secure. We utilize all of the security protocols that AWS actually uses. Security is of prime importance to us, and we use all those security protocols like using security groups, ACLs at the subnet level in your VPC, and even the data that is flowing through your replication instance, if it ever goes into the disk, it's encrypted at rest using our key management service and things like that. It is easy to use. You could use it from the console. We have API calls exposed via CLI and other SDKs like Python, Java, Node.js, and everything. So it is easy to use, and you can use it any way you want. It allows DB freedom. You can, like I said, you can go from any of our supported sources to any of our supported targets. It is cost effective. We have customers moving more than a TB of data, spending less than $3 at a given point in time. And you can keep a leg in the cloud. You can actually migrate your databases into the cloud, because the only requirement to use the database migration service is to make sure at least one of your endpoints is in AWS. It could be the source or it could be the target. One of your endpoints is in AWS, and this service actually helps you keep a leg in the cloud. The other advantages are modernize, migrate, and replicate. Modernize, where you can decide that certain portions of your database need not reside in SQL Server anymore. You could go into our other awesome services like Aurora MySQL or Aurora Postgres. You can modernize your reporting solutions or your data warehouse solutions and move your some of your reporting workloads into Redshift. From the migration perspective, because it supports ongoing replication, you can migrate your business critical data and go about making sure the target is in complete sync with the source before you actually migrate to a newer box or a newer instance or into RDS as such. And you can also go about replicating databases and data into AWS using the ongoing replication feature. And it's just that the other features like multi-AZ just complement this feature in a good way to make sure you have 100% resilience in your migrations and make sure we minimize your downtime there. With that, let's look at a demo as to how exactly to set up those artifacts like how I talked about, and show you how you can move a SQL Server database into AWS using the database migration service. So let's go into the demo here. I have a SQL Server Management Studio up here with a couple of connections on the left. What I'm going to try and do today is I'm going to try migrating a database. So one of the instances that I just highlighted is an EC2 instance, and it runs a SQL Server instance on that. I run a SQL Server instance on that EC2 instance, and I'm going to try and migrate this particular database called DMS-SQL which contains these tables that I'm talking about into an RDS SQL Server instance, and show you how to do that using DMS. So one of the ways I am going to do this is this DMS sample database is an empty database that I've created, and it does not contain anything right now in the RDS instance. But let's go into the console. This is the DMS dashboard in AWS. Let's go through all those steps we talked about there, where I was talking about the actual process for the DMS migration as such. One of the things that you need to do is to create a replication instance, and you do that here in the replication instance tab. You just go about, once you have the appropriate permissions, you go about giving in a friendly name, a description, choose your own instance class that you need to use. There are best practices around choosing the right instance class that we have a white paper on, which we'd be more than happy to share with you guys. And then go about choosing the appropriate VPC and creating your own replication instance that is going to show up as available once it's available. So what I'm going to do for this demo is use a replication instance that I've already set up previously, just to save some time. And then the second step is to go about creating your source and target endpoints. So let me filter it out just to show you the required endpoints here. So I've already created the source and target, and if you look at it here, let me show you what I'm talking about, I have an endpoint identifier, an endpoint type, which is depicting whether this endpoint is a source or a target, the source engine, the server name. This is my EC2 instance that I'm trying to connect to. And like I was talking about, I'm using the system administrator privileges and trying to migrate the DMS sample database. So you would have to create a source and a target endpoint. And if you closely look at it, I am trying to migrate it to an RDS instance in my AWS VPC and trying to migrate it into that empty database that I showed you guys in the previous screen from the management studio there. The third entity that you would need to create is the migration task as such. You go into the task tab right here and you go about creating a task. I had another task that I wanted to quickly show you numbers on, but let's go ahead and create a new task to show you how this particular service works, and we will take it from there. I'm just going to choose the replication instance that I created, choose the SQL Server source and the SQL Server target. This is going to depict that I'm trying to migrate from that particular source endpoint that we created in the previous set of tabs we saw into this particular target. And like I was talking about, we have three different types of migration. Migrate existing data is that bulk load only phase. Excuse me. And migrate existing data and replicate ongoing changes is something which is going to migrate the bulk data and keep your target in complete sync with the source at a given point in time. Replicate data changes only is just going to do the replication part where the bulk load is going to fall back on yourself. I'm just choosing the full load plus CDC. And for the purpose of this demo, I am not going to use SCT because it's a homogeneous migration as such. And I'm just going to let DMS, just for the purpose of this demo, I'm just going to let DMS create the table structure, the primary keys, and migrate the data. But using SCT or native tools to migrate the objects should be pretty straightforward. So moving on from the task settings, let's quickly talk about the target table preparation mode. There are three ways to do this. The first one assumes that you have created those tables yourself on the target, and DMS does not try to do anything while migrating the data. The second and third options depict that DMS has abilities to drop tables on the target and create those tables according to the data type conversion logic that is defined in our reference section in the documentation. So if you go look into our documentation, you will see a references section which talks about mapping the source data types to target data types in case you wanted DMS to do that. And the third one is a truncate only option, which does not touch the table structure if the tables are already there, but it's going to truncate that table and make it empty before the migration starts. But it's going to create the tables using the same data type conversion logic I talked about in the previous step if the table is not present as such. One of the other cool features about DMS is it's going to stop the task. It has abilities to stop the task after full load completes, where you can stop the task before something called applying cache changes. Because let's say a full load starts at time T1 and ends at time T2. There could be changes going on in that table between time T1 and T2. So that is the phase that it goes into after the bulk load phase, where it's going to apply all those cache changes. And that cache changes application is kind of transactional. So it is recommended that you have all your indexes, secondary indexes in place when that happens for it to move on as fast as it can. So people typically stop the migration task before applying cache changes to add those secondary objects like indexes. And then they stop the task after applying cache changes because they need to add foreign keys and other constraints after applying cache changes. Because so the other important point here, I guess, is you absolutely cannot have foreign key constraints or referential integrity constraints during the full load phase because the load is table by table. And then you go about choosing your lob columns, specify how big your lob column is for the limited lob mode and what the lob chunk size is for the full lob mode. I would recommend looking through our best practices white paper to know more about this. And this little checkbox enables logging for the migration, where because DMS is a managed service, you unfortunately do not have access to the underlying host, but when you check this, it's going to create those logs in your CloudWatch in the CloudWatch console where you can go look at the logs. And then you choose all my tables are in the DB or schema. So you choose in this wizard, you kind of choose what tables you need to select in order to migrate, and then add a selection rule. And once you do that, and once the start task on create is selected, you create task, and boom, it's going to help you migrate from that particular source onto that particular target. In the interest of time here, because we need to move into questions after this demo, I'm going to show you some numbers from a previous task where it tried to move. This is about a 15 gig data set. It tried to move about 18 tables for the 15 gig data set in about 24 minutes. So let me show you some numbers here. You would be able to, this was run a bit a while ago, you would be able to see some of the task monitoring stats within the task itself. But some of the table stats as such are going to show up here, where it's going to show you the total number of full load rows, which is the bulk load rows that went on during that particular migration. And then once it goes into CDC, it's also going to show you different types of CDC events like inserts, deletes, or updates that went on during this particular migration. For example, if you look at this truncation safeguard table, it got 8 updates during that migration before I kind of went about stopping it. Now, let's the other thing I quickly wanted to show was even on the replication instance side of things, you would be able to see all the monitoring metrics from CloudWatch, look at different things like CPU utilization, the amount of storage space being occupied in the underlying replication host, and other metrics that are relevant for the performance of the migration here. So now let's go back and look at the running stats for this particular migration. So if you remember correctly, we did not have any of those tables created in the previous RDS instance, and now that the task has started, it's going to have to create those tables right now. Give me 1 second. There you go. So DMS is responsible for creating those 18 tables like we talked about, and the task is currently supposed to be running. And if you actually see some of those numbers here, full load means the table is currently being processed and the load is going on, while table completed means the full load phase has completed and it's moved on to the ongoing replications phase, where now if I go about adding data into any of these tables, DMS has abilities to read those changes from the transaction log and start applying them directly on the target there.